Hi and welcome to this new video. Today we will see which tool is the fastest for analyzing small to medium large datasets in R. And we will try all the tools that you see in this slide: data table, arrow, duckdb, polars, dplyr, and dplyr. Before starting to see the results, I want to show you the environment configuration. So I used R 4.4.1 and the latest version of all of these packages as for August 2024. And here you can see also the components of my system. Now we will talk about the experiment configuration. And in total, I ran 4 different tests that you can see in these different columns. In the first one, I used a dataset with 500 million rows by 4 columns. I grouped by 1 column and I had a result of 27 rows by 4 columns. And I ran 10 iterations of this test. So the command that I used is this one right here. So I use the data, I pipe it into the group by function to group by the first column, and I summarize the other columns. I got the mean of V, the sum of C, and the frequency. The test C used the same command, but in this case I had only 1 million rows, so I could run more iterations. I ran a total of 50 iterations and I averaged them. Then we have the test number 2 and the test number 4. In the test number 2 we have 100 million rows. In this one we have only 1 million, but you see that we have 5 columns and we group by 3 columns. So for these 2 tests we use this command. So I group by 3 different columns and I get the summary of the other 2 columns. So the mean of D, the sum of E, and also the frequency. So in these 2 cases, the result was a table of 17,000 rows by 6 columns. And in this test that we have more rows, I ran only 10 iterations, and for this one I ran 50. Alright, so now we will see how I did this benchmark, and more specifically we will do the test number 3. I will start loading the packages. In the case that you want to do this, the tidy polars package is not in CRAN, so you need to install it from our universe. The rest of them are in CRAN, so I'm loading all of them with pload. And then I will create some data. And here I will execute this and I will print it in the console. What I'm creating is a table with 1 million rows and 5 columns. The first column, the column A, it's taking the letters. So if I print this, they are all the letters from A to Z. And I'm repeating them 1 million times with replacement. And then I'm doing the same with the column B, the column C, and then with D and E, I'm creating integers from 1 to 100. So now what I will do is to write this table into a Parquet file. So I will create it, I will save it, and now we can check the file size. And here we see the file size in megabytes. So this one is quite small, it's only 3.5 megabytes. Now what I will do is to store this data into a duckdb database. So here I'm creating it with this db connect. So I'm creating this database, data test doc.db, and then I'm writing the table in this connection that we created. I'm giving it a name of test data. I'm writing the test table that we created here, and I'm overwriting it. So I will execute it, and now it's already inside the database. Then for the different formats that we will test, we need to use specific formats. So this is the format for data table, which is, we can check the class of this object, and you will see that it's data table and data frame. Then we have the polars table that looks like this, the dplyr table, which is slightly different from data table, and finally the duckdb table, which looks exactly like a table, but if you use the class function, you will see that it's a duckdb df. Alright, so now we can do the benchmark, but first we will define the functions that we will use, and we will take the data that we created before, and we will summarize the mean of the column D, the sum of the column E, the frequency, and we will do it by three groups, A, B, and C. And you see here that I'm not using the group by function, and this is new syntax for dplyr function, so I prefer to use this one rather than group by. And then we are creating the function for data table. And here the format is different. So here with the brackets, we are selecting all the rows. And then after the comma, we are applying some function. So we are obtaining the mean of D, the sum of E. With this dot n, we are getting the frequency, and then we need to specify this by, which is equivalent to the group by. Alright, so I will execute it, and finally we have the function for the polars package. So here we use the S3 method, so object-oriented programming. So we are applying the method group by to the data, and we are grouping by these three variables, and then with another dollar sign we are aggregating. And in the aggregating we are taking the column D and calculating the mean and giving it a new name, which is mean D, and the same with the others. We take the column E, we apply the sum, and we give it a name. Alright, so I will execute it, and now I will execute the next function, and in the meantime I will show it to you. So here I'm using the mark function from the bench package, and here I am defining different names, which you can put whatever you want here. So I'm putting just the name of the different packages that we are using, and inside the brackets you need to introduce the code that you want to execute. So for arrow, I'm opening the dataset, the Parquet file that we stored in our file system, and applying the function and then collecting the data. For data table, I apply the function that we created before. For the dplyr, we use the base function, and then we need to collect the data to get the table. Then we use the db get query for duckdb, because here we need to use SQL if we want to use the duckdb engine. So here I'm using the connection and writing the query in SQL. Then with duckdb dplyr backend, we can use the tbl function to access the connection. So this is similar to this structure. We get the connection, then we say we tell the table that we want to take. So I can print it in the console, and we see this. Then we apply the function. Actually, when we use this, we don't apply the function, we are creating the query, and when we use the collect function is when the query is applied. So if I execute, here you see that we have the result, but before we don't know how many rows we have because the functions are not applied until we use collect. Then we have here the method for duckdb, and this one we will ignore it because there is something wrong, and I will show you in a moment. Then we have the dplyr function, the dplyr package, which is just using the test table with the function. Then we have polars, tidy polars, which uses the base function. And finally, I added these two arguments, the check equals to false, because some of them have different formats. And if we have this equals to true, the function will retrieve an error. And then I'm running each of these functions 50 times. And now we already have the results, and I will print this in the console. So results. And here we have the different expressions, which are the names that we introduced here, the minimum time, and the median, which are the values that I used for the graphs. And here we can see that in this case, you will see that duckdb is the fastest one. And this is some error because I don't know why with the benchmark function, if I execute it here, you will see that in average is about 6 milliseconds. But if I use TikTok, which I need to load, library TikTok, you will see that in reality this one takes a bit longer. So you see here 0.17, but in this case is 0.006. So is this number, and here when I run it 6 times, it was all of these values. So I use this one and then I change it in the results table because this is something wrong and it was only happening with this package. So I will print it again and you can see in this example data table was a bit better than duckdb, but it's the first time that it happens actually for me, even though they are quite similar. All right. And if you execute it again, you can have slightly different results, but I run it more times, and most of the times I have a DuckDB that was the fastest. And maybe because now I have some programs opened, it's changing the performance of them. Okay, now we will comment out the results of the tests. And we will start with the test number 1, where the test had 500 million rows, 4 columns, and we grouped by 1 column. So in the top 3, we have all the packages related to DuckDB. So DuckDB was the fastest with 1.47 seconds. Then we had the dplyr backend for DuckDB, which was slightly slower, but very similar to DuckDB. And then we have duckplyr, which was 2.6 times slower than DuckDB. Then we have Arrow, which was more than 5 times slower. We have Polars, dplyr, which was similar to Polars, and it's something that surprised me. I wouldn't expect dplyr to be as fast as Polars in this case. And then we see Polars, which was slower. And finally, we have the thing that surprised me the most in this test, which is that data table and dplyr were the slowest ones. If you have any thoughts why this happened, please leave it in the comments. Now we will explore the results of the test number 2, where the test had 100 million rows and we aggregated with 3 columns. So these results are more consistent with what I would expect before running the tests. So we see that the top 2 is again the same. We have DuckDB the fastest with 2.26 seconds. The dplyr backend for DuckDB was very similar. And then we have the dplyr and data table, which in the previous test they were the ones in the tail of this graph, but now they are the third and the fourth one. So this is what I would expect. Then we have duckplyr, which fell 2 positions, so it's still very fast because it's 1.5 times duckdb, but in this case it was slower than the dplyr and data table. Then we have polars, arrow, tidy polars, which are more or less as they were in the previous test. And finally we have dplyr, which is what I would expect, that dplyr was the slowest one. And in this case you see that it was almost 7 times slower than duckdb. Now we will explore the results for small datasets. And here the dataset had 1 million rows and we aggregated by 3 columns. And here the top one is again our friend duckdb. Then we have polars, which in this case is the second one, and before it was here, so it was the sixth one, and before it was the fifth one. So it improved a lot with the smaller datasets, but it's also in the same position with data table because they are 1.2 times slower. Then we have dplyr, which in this case it was slower than data table. In the previous case for bigger data, dplyr was fastest, but now data table is fastest. And then we see that duckplyr fell down to this position, and also the dplyr backend for duckdb now is 6 times slower than duckdb. And we have again dplyr in the tail of this graph with 13 times slower than DuckDB. But one thing to note here is that this is a small data set and none of them took even 1 second, not even half a second. And finally we have the results of the test number 4. And here we have again a small data set summarized aggregating by 1 column. And the results are again, the winner is again DuckDB with 0.03 seconds. Then we have polars, about 3 times slower, data table, and here we have dplyr better than other packages. It's more or less the same as the dplyr, but then we see others that are slower. And we can see how the dplyr backend for duckdb is much slower with smaller datasets than what we saw with the two first ones. We see that duckdb dplyr is here the second one, here is also the second one, but in the test number 3 and in the test number 4 is in the last positions. Now we will talk about the results of memory allocation, and more specifically the memory allocation in test number 1. And memory allocation is referring to the process of reserving some portion of the computer's memory to be used by a program or process. In this case, it means the quantity of our RAM that will be used by R when using a specific package. And here you can see two different clusters. In the first one, we have disk-based systems where the memory allocation is very low. You can see that in all of them is less than 1 megabyte. And then we have in-memory systems where the memory allocation is pretty big. So you can see that dplyr and duckdb they are allocating about 12 gigabytes, and data table and the dplyr they are allocating about 13 gigabytes. So those that are disk-based, they are designed to handle large datasets efficiently by operating on a disk database. So what they do is to split the data in different chunks, and they don't need to load all the data at once in the memory. So they pass chunks of data to the disks and it's processed there. And the ones that are working in memory, they use all the data and they process it in the RAM. In this sense, in-memory systems may limit us when we want to use bigger data sets than the ones that I used in these examples, because I tried to run tests for all of these packages with bigger data sets, but those that work in memory, they were giving me problems. So if I wanted to run tests with bigger data sets, I could only try these first packages because in those wouldn't work. We will finish up with some conclusions. DuckDB is the fastest tool in R for analyzing medium to big datasets. The dplyr backend for DuckDB allows us to use the dplyr burst, taking the advantages of DuckDB speed without losing any performance. Data table and the dplyr are generally fast, but they might be slow with some queries, and they might be also limited by our RAM. Polars was between 2 and 6 times faster than dplyr, but much slower than duckdb in test number 1. Arrow performs well with big datasets, but almost 6 times slower than duckdb in some cases. We cannot draw any clear conclusion in small datasets because the computing time was very slow in all cases, but duckdb won all the comparisons. And finally, if we wanted to run the tests for bigger datasets or more complex queries with big datasets, in-memory based systems are problematic for the machine that I used for these tests.